Right, so the second task is process scheduling. This again is an entire topic in itself. There are scheduling algorithms which we will be looking at in quite some detail. So the basic idea of scheduling is when there is one CPU and multiple processes waiting to be executed on it, they have to be scheduled or ordered. The sequence in which they get executed needs to be designed. So it is like sort of like standing in a queue at a bank or post office. There's only one cashier and there are 10 of us standing in a queue. Generally the order in which the queue gets serviced is first come first served. So the person who arrived first will be serviced, followed by the person who arrived second, and so on. That is how queues in real life are generally serviced. But when you come to the computer, when you look at processes on a system, that is a possible logic but might not always be the best option to adopt, because let us say you have one CPU and there are 10 tasks waiting to be serviced by that CPU. It is possible that the fifth or sixth task is more urgent, it is high priority. So it does not make sense that the sixth task has to wait for 5 tasks to be finished, because the sixth one could be more priority. Or it could be that task number 1 is extremely time consuming and all other 9 tasks are those that can be finished in an instant. So in that case, it would make sense to finish those 9 smaller jobs first and then do the time consuming job, right? So because there are all sorts of such complexities involved in terms of the nature of the task, the kind of resources. Yeah, so resources, this is another thing. Maybe process 1 is, the CPU wants to execute process 1 right now, but process 1 has been held up because it requires some input or something. So now you have to wait till that input is given, and then process 1 will be executed, and then 2, 3, 4, 5 and so on. Whereas if you could pick up process 4 and work on it until this input is given, it would save time, right? So ultimately the idea of a computer, idea of the idea of an OS or a CPU is to maximize the output in minimum time. So for that you need to sequence the order of execution of processes appropriately. So that is what we mean by process scheduling. So so there are multiple algorithms for this. We have first come first served, we have shortest job first, we have round robin, we have so many, and we will be looking at them in a subsequent unit. As of now, the idea of process scheduling is when you have multiple processes waiting to be executed, the OS will decide in what order they get serviced. So there's a point I mentioned here, balance between input-output heavy and CPU-heavy processes. So this is, the idea is, like I said, let's say there is one process which needs support from an input device. So some input needs to be given. There are other processes which require only CPU. So instead of putting things on hold and waiting for the input-output process to be completed, if you can tell that input-output process to wait until the input is given, and in the meantime if you can work on some other process which only needs CPU. So that's what I mean by IO heavy and CPU heavy. So while that input is being collected or parsed or whatever, instead of staying idle, if you can pick up another process and finish it off using the CPU, you're going to save some time. So that is the balance between input-output heavy and CPU-heavy processes. So this ensures that both your input-output devices and your CPU are occupied most of the time and nobody is sitting idle. So all these calculations are performed by the OS.